Hello everyone, in this lecture I am going to discuss about the basics of microwave and radar engineering. So this subject is for ECE 7th semester students. I am Dr. Karunesh Srivastava from AKGEC Engineering College. So first of all, what is vector and what is a scalar? A scalar is a quantity that has only magnitude. For example, time, mass, distance, temperature and populations. We can represent the vector quantity by a letter, simple capital letters. So what is a vector quantity? Vector quantity is a quantity that has both magnitude and direction. The examples for this vector quantity is velocity, force, displacement and electric field density. We can represent the vector quantity in bold letters, or we can write capital letters over that. You can write a arrow. So we can write this as a magnitude multiplied by the unit vector, where the capital A represents, or magnitude of vector A is nothing but A. So if a vector quantity, if a vector just like in x, y and z direction is given like this: ax, ay plus az, then what will be the magnitude of this? The magnitude for this vector is magnitude, this is a vector quantity, so mod of A is nothing but under root of ax square plus ay square plus az square, where small ax, ay, az represents the unit vector, or you can know this represents the direction of the vector. Now what is a unit vector? A unit vector along A is defined, along vector A is defined as a vector whose magnitude is unity and its direction is along the direction of vector A. So what is the unit vector? Mathematically you can write this unit vector A cap is equal to vector A divided by the magnitude. So in this way we can represent the unit vector. Now coming to the dot product multiplication of vectors, multiplication of scalar quantity and multiplication of vector quantity. So we can multiply the vector quantity in two ways, that is dot product and cross product. Suppose there are two vectors, vector A and vector B, then and vector A is written as ax plus ay plus az, or you can write in coordinates form. Similarly we can write the vector B, that is for the Cartesian coordinate system, that is bx by bz, or bx ax plus by ay plus bz az. bx by bz, ax ay az is the magnitude of vector in x, y and z direction. So what will the dot product for this? Dot product is simply the multiplication of magnitude of two vectors in that particular direction. So A dot B is equal to ax bx plus ay by plus az bz, which is simply obtained by multiplying the A components of A and B. Now coming to the cross product. The cross product, one more thing, in dot product you can write like this: A dot B is A B cos theta, vector mod A mod B cos theta, where cos theta represents the angle between vector A and vector B. Similarly, the vector product, the cross product, the vector product or cross product, vector product of two vectors A and B can be written as A cross B is equal to mod of A mod of B sin theta AB, n cap. So, theta AB represents the angle between vector A and vector B. The product of cross product is always a vector quantity, whereas the scalar product or dot product of two vector quantity is always a scalar quantity. So, you can remember this. If I am going to do the cross product of if I am going to do the scalar product or dot product, if I am taking a dot product of two vectors, then we will get the scalar quantity, and if I am going to take the cross product of two vectors, then I will get vector quantity. Theta AB represents, or theta in the previous case of cross product, represents the angle between two vectors, vector A and vector B. Now, how will you find the cross product? Simply we have to take this matrix. AX, AY, AZ represents the direction of the magnitude. So, you can write like this: A cross B, vector A is equal to AX, AX plus AY, AY plus AZ, AZ. Vector B is equal to BX, AX plus BY, 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 BX, AX plus BY, AY plus BZ, AZ. So, you can write like this: AX, AY, AZ. You can write the components of vector A and vector B in the direction of X, Y and Z. So, it will be like this, it will be like this. Now, you can write simple, you have to solve the simple matrix. So, by solving the matrix, you will get this quantity. So, you can see here this cross product is again a vector quantity which represents the magnitude in X, Y and Z direction. Now, how will you show the direction of the vector? So, if the angle is this figure shows the direction of A cross B. So, you can use the right hand rule or right hand screw rule. So, it is clear from this figure, you have to show the angle in which direction the angle between the two vectors. So, by showing this, you can see that this A cross B is the perpendicular to the plane of A and B. Similarly, from the right hand screw law, you can see that this A cross B is perpendicular to the plane of A and B, vector A and B. Now, coming to the basics, these are the orthogonal coordinate system. Basically, there are three type of coordinate system: rectangular or Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. So, coming to this rectangular coordinate system, in rectangular coordinate system we have x, y and z coordinates. So, here I am not going to going in detail, I will discuss only some basic concepts. So, I am discuss what is the differential area, what is the differential length, what is the differential area and what will be the range of x, y and z. So, you can see here this is the figure of coordinate system. Here x, y, z and x, y and z coordinates are here. So, if I consider a point P whose coordinates are x, y and z, then what will be the range of these variables? So, you can see here this x can vary from minus infinite to infinite. You can go in this direction perpendicular to this, or you can go in negative x direction. So, you can consider the range of variable x is minus infinite to infinite. Similarly, for y, it varies from minus infinite to infinite. You can go in positive y direction as well as in negative y direction. And similarly, for z direction, you can go in plus z direction up to infinite and minus z direction to minus infinite. So, the range for z direction is minus infinite to infinite. So, for the point P whose coordinates are x, y and z, the range of these variables will be minus infinite to infinite. Now, consider a vector whose magnitude in x, y and z direction is ax, ay, az. So, the vector A for this will be ax, ax plus ay, ay plus az, az. Now, coming to the cylindrical coordinate system. Cylindrical coordinate system, there are three variables rho, phi and z, or you can say cylindrical coordinate system can be represented in rho, phi, in three coordinates, three coordinates are rho, phi and z, where rho represents the radius of the cylinder, phi represents the angle made with x axis, and z represents the height of the cylinder. So how can you prepare, how can you make this cylinder? By considering in x, y and z coordinate, I have considered here a point x p. This point p, I have considered this plane p, this plane lies in x y plane. This plane lies in xy plane. If I rotate this plane, and this plane is making angle phi with x plane. If I rotate this plane with respect to z axis, then it will make a cylinder whose height will be z. So from here we can get the range of the coordinates or variables rho, phi and z in cylindrical coordinate system. So here you can see the phi can vary from 0 to 2 pi for making a circle or for making a cylinder. So if I vary phi from 0 to 2 pi, then I will get a cylinder. And what will be the height of this cylinder? Height of the cylinder will vary from minus infinite to plus infinite. And what about the rho? Rho is the radius of this. You can see here, this is the rho. So rho can vary from 0 to infinite. So radius of that cylinder may be can vary from 0 to infinite. So this is the way you can get the range of these variables. So these three variables are rho can vary from 0 to infinite, phi can vary from 0 to 2 pi, and z can vary from minus infinite to plus infinite. Now, what are the unit vectors in this case, and what will be the direction of these unit vectors? I will consider the direction of these unit vectors where these variables are increasing. So phi is increasing by rotating the plane in anti-clockwise direction. So the direction of this, what will be the direction of unit vector a phi? Unit vector a phi will be in this direction, which will follow the curvature of that cylinder. Now, what will be the direction of z? The direction of z is increasing in upward direction. So we will consider the unit vector in z direction in positive z direction. And what about the phi? Phi is increasing in this direction. You can vary the radius from 0 to infinite. So the direction of a phi will be outward direction. So this is the method. This is the method you can represent the unit vectors of any coordinate system. You have to consider the only increment of that variable in particular direction. Now, you can see here the dot product and cross product of unit vectors. So the dot product of same variable in the same direction will give the unit, and dot product of opposite vector or different unit vectors will give the 0. How it is possible? You know this because dot product of any two vectors can be represented as a dot b is nothing but ab cos theta, where cos theta represents the angle between vector a and vector b. So if I am taking the dot product of same vector a rho dot a rho, the angle between these two vectors will be 0 and the value of cos 0 will be 1, and the magnitude of unit vector is always 1. So the dot product of same unit vector will give the unity. And if I am considering the dot product with another vector, then it will give 0. Why? Because these unit vectors are perpendicular to each other. Similarly, cross product You can write like this: rho, phi and z. A rho cross A phi, if you are moving in clockwise direction, A rho cross A phi will give AZ. A phi cross AZ will give A rho. AZ cross A rho will give A phi. This is true. Or you can say this cross product is positive only in case when you are moving in clockwise direction. If you are moving in anti-clockwise direction, then this cross product will be negative. So in this way we can represent the dot product, cross product, range of variables in cylindrical coordinate system. Now how will you correlate the Cartesian coordinate system to the cylindrical coordinate system? I have already considered here the point P whose coordinates are x, y and z. So this coordinate x, y, z is equal to rho phi z in cylindrical coordinate system. So by moving this plane in anti-clockwise direction, I have created a cylinder in rho phi z or cylindrical coordinate system. So I have to map this x, y, z into rho phi z. So this what I have to do, this point is from plus z direction, this point is at z distance from this xy plane. So you can see here, and this plane is making angle phi from x axis. So what I have to do, I have to find the relation, because this x and y axis is perpendicular to each other and we are making this angle phi. So this angle will be 90 minus phi. What will be the value of this and what will be the value of this? You can consider this angle is 90 degree actually. So what will be the value of this? This will give y is equal to, this is the amplitude in direction of phi, this is the amplitude or magnitude in the direction of x. So this is rho sin phi and this is rho cos phi. So you can write here x is equal to rho cos phi and y is equal to rho sin phi, and you can find the relation between x, y and rho phi. Here you can write y by x is equal to tan phi and rho is equal to x square plus y square. Z is same, only the different variables are rho, phi, x, y. Z is same. So you can see here the transformation points from P rho phi z to P x y z is x is equal to rho cos phi, y is equal to rho sin phi and z is equal to this, rho is equal to this and phi is equal to this, tan inverse y by x, z is equal to z. Now coming to the spherical coordinate system. In a spherical coordinate system, the variables are r, theta and phi. So for making a sphere, I am always considering the xyz coordinate. In xyz coordinate, I have to transform that xyz coordinate into the cylindrical coordinate system. Similarly, I have to transform the rectangular or Cartesian coordinate system into the spherical coordinate system. So how will I make a sphere in xyz coordinate or xyz plane or Cartesian coordinate or Cartesian or with the help of Cartesian coordinates? So what will I do? I will take a point P which is making an angle at distance r and which is making an angle of theta with the z direction. So you can see here I have to prepare a hemisphere. For making a hemisphere, I have to, first of all, I have to make a circle. For making a circle, I have to vary this phi from 0 to 2 pi, and for making a hemisphere, I have to vary this theta from 0 to pi, or you can say if I want to make a circle, so you can see here for making a circle I have to vary for this theta from 0 to 2 pi, and for making a circle in this plane I have to vary phi from 0 to 2 pi. So and what will be the value of r? The value of r will be from 0 to infinite. So and what will be the direction of unit vectors? The direction of unit vector will be in the increasing direction of r, theta and phi. R is increasing in this direction, theta is increasing in this direction. So theta is increasing in clockwise direction. So I have considered a theta in this direction. And what about a phi? A phi is varying like this, so I have considered this a phi. Phi is varying in this direction. So in this way you can make a hemisphere. So for understanding the range of variables, you should know how will you make a cylinder or a sphere in x, y and z coordinate system. This is again the dot product and cross product of spherical coordinate system. So you can again see here the dot product of same vector will give the unit quantity, and dot product of the different unit vectors will give the 0. And what about the cross product? Again r, theta and phi, you have to, if you are moving in clockwise direction then it will give the positive value, if you are moving in anti-clockwise direction then it will give the negative value. So ar cross a theta will give a phi, a theta cross a phi will give ar, next variable, a phi cross ar will give a theta. So this is the way you can get the cross product and dot product of a spherical coordinate system. Now, how will you map these spherical coordinates with Cartesian coordinate systems? So in the previous case, that is in spherical coordinate, in a cylindrical coordinate system, I have considered p x y z is equal to p rho phi z. Now I am going to discuss this Cartesian coordinate system, this spherical coordinate system. So what will I write? I will write p r theta phi. I have considered this point P at distance z from this plane. So this plane, this plane was formed in case of cylindrical coordinate system. By varying this phi from 0 to 2 pi, I was getting a circle at the base of the, or you can say in xy plane. And I have already find this value of x and value of phi, value of y by considering this angle phi and this angle 90 minus phi. So x is equal to rho cos phi, y is equal to rho sin phi, and the value of this plane, or you can say the radius of this cylinder is rho. So by varying this plane which is lying in this yz plane, by varying this plane in from 0 to 2 pi, you are getting the cylinder. And now I am getting the circle. What I have to do? I have to move this point from 0 to pi for getting this sphere. So this is z is equal to z, and I have to write in terms of r. So this is the value. The value of this z will be same. The value of this z, how will I get this? I have to find this angle is theta. What will be the value? This will be 90 minus theta, because this angle is theta. So this plane is in the making the angle 90 degree with this plane xy. So the value of z will be equal to r cos theta. This will be the base, and this will give the z is equal to r cos theta. So in this way we can get the value of x, y and z. So this is the point transformation from spherical coordinate to Cartesian coordinate system. So in the previous slide I have written here x is equal to rho cos phi, y is equal to rho sin phi, z is equal to r cos theta. rho is equal to r sin theta. By putting rho is equal to r sin theta, you will get x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. What will be the value of r? By squaring these two equations, you can get r is equal to under root x square plus y square plus z square. And what will be the value of theta? Theta is nothing but you can get from here, this will give x square plus y square is equal to r square, and z is equal to r square sin square theta. So you will get here r sin theta is equal to under root x square plus y square. R sin theta is equal to x square plus y square, r cos theta is equal to z. So what will be the value of tan theta? You can divide this equation by this equation. R sin theta by r cos theta will give the value of tan theta, and this will be equal to x square plus under root x square plus y square by z. And phi is equal to tan inverse y by x. You can get from here, divide these two equations. Say this is 2, this is equation 1. Divide equation 1 by equation 2 and you will get the value of phi. So this is the way you can transform the Cartesian coordinate system into the spherical coordinate system, or spherical coordinate system into the Cartesian coordinate system. So this is all about the basics of the coordinate system, and this is the prerequisite for the microwave and radar engineering. Thank you.